So if you have your calculators ready to go, you just got to make sure it's set to degrees. One way to check it is if you go sine and then 30. If you go sine 30, it should tell you, it should show 0.5. If you're not seeing 0.5, then your calculator settings are off. Some of you have maybe a D at the top. That's good. That's degrees. But if it's G or R, you don't want that. One is gradients, one is radians. Okay, so you don't want those. So making sure you have that setting. If you have issues with it, come and see me later. I will help you out with that. Okay. Have a few highlighters ready. So in previous years, you've learned how to solve for missing angles or sides with a right angled triangle, okay? But in this course, we're going to learn how to solve for oblique triangles. Oblique are triangles that are not right triangles, okay? And the first way to solve this is going to be sine law. The second one is going to be cosine law, right? Well, maybe not. Maybe you haven't heard of it, but there is no tangent law. Like, you know how it was SOHCAHTOA? It's just sine law, cosine law. That's all you need to solve any triangle, okay? And so this is sine law here in a nutshell, okay? If you have a triangle like this, I need you to understand that a capital letter is there for angles, and if you watch the lesson from pages 2 to 3, if you fill that in, you will know, okay? That angle corresponds to that side that's across from it. And then this angle over here corresponds to the side that's opposite to that. There's a very important pattern you need to understand, okay? And this last angle here corresponds to the side length across from it. So there's, if you want to look at it that way, there's 3 pairs, okay? There's 3 pairs, and you always want to keep them that way. So for sine law, if you want to have on your study sheet an entry, you should have trigonometry, right? You should have a trig section, and then sine law is right here. This is what sine law is telling us. That if you take the sine of the angle and you divide it by the side that is across from it, it's going to be exactly the same as taking the sine of E, another angle in that triangle, and the side across from it, which is going to be exactly the same as sine F and the side across from it. So see how that pairs up? So let's use the same colors. D was orange, right? So you should see that these two are opposite each other. That is what matters. F, we used pink for F. That is the pair right there. And the last one was E, right? Which I used yellow for. There it is. So that's important that you always pair them up accordingly. There are 3 scenarios, distinct scenarios, where you know for sure it's sine law. Okay, so you're gonna have to pick. So it's the one where you may have 2 sides. You may have 2 sides known, like this will have a number attached to it, and you have an angle across from one of them, okay? Then you see that there's a pair there, a known pair. Boom, you know it's sine law. Without a doubt, this is going to be sine law, okay? No questions about that. Another case is where you have 2 angles that are known, okay? And you might have the side length across from one of those. So guess what? There's your pair. There you have sine law again. And the last case is where you have, this one is not so obvious. You've got 2 angles, and you've got the side length here. Does this look like you have a pair right now? Can you find a pair? What happened? Yes?
Subtract the 2 angles from 180.
That's right. So 180 minus check mark now you have that one, okay? This gets back to the property where the sum of angles in a triangle is 180. So guess what? Now you have your pair. So don't despair when you see this one. You still have a pair. Okay. So I call this the hidden pair. What I will suggest to you is this. If you have two angles, find a third one. Just go ahead and find it. It's going to make everything so much easier. Okay? If you have two angles, go find a third one. Boom, you've got a pair. And I will highlight that one big bolded statement at the bottom. If you have a pair, if you have a side angle pair, use sine law. Okay?
Yeah.
Leave him alone. He's paying attention. Sine law, okay? So let's go back. If you're working on your study sheet, okay? I'm helping you out here. I'm going to help you out with this one. If you have this on your study sheet, I would say, you need a pair. And more specifically, I would have a triangle drawn like this, where you have like the pair kind of circled. I would suggest you add that to your study sheet. I would add that to my study sheet at some point, yeah. We're good? Why are you all so excited? You look way too excited for this. Okay, let's put it to use. So we're going to start with figuring out the side length, then we're going to figure out the actual angles, okay? So side length first. I'm quite confident that after one example, you're probably going to have a pretty good idea of what to do. Okay? So here it is. Oops. Why is it all off here? Okay. Calculate the length of side A. So it wants this side right here. That's the question mark. Do you have a pair?
Yes.
Yeah, it's right here. So I know right now we don't know how to use the cosine law, so obviously you're not going to run into that scenario, but you know it's going to be sine law that you're going to have to use. So let's solve for that. So I'm going to just. So we go like this: sine of 52 degrees. Let me back up. Sorry about that. I hope you're not using pen. I'm going to, before I do this, normally this is fine going straight to this, but I'm going to see, like, which pair do we have? It's B, right? Angle B, side B. So technically, we're going to take sine of angle B over side B, and we're going to, if you want to solve for side A, that's the one you want to solve for, we're going to have sine of capital A on top. And you might think, why are you not using the third one, Mr. Derrickson? You just told us that there's 3 of these, right? You only ever want to have 2 paired up like that with an equal sign in between. It's just saying that it is true that all 3 of them are the same, okay? So you wouldn't want to go is equal to sine of C over side C. That's just too much, right? And now let's substitute. I started with this because I have both of these numbers. So you go sine of 52 degrees over 16.8 centimeters. And then sine of A is 72 degrees, right? It's right up here. And that'll be over side A, like that. And what does that look like? Cross multiply and divide, doesn't it? Yeah, that's what it is. So you go to the side where the variable is. You start with the number. So we cross multiply and then divide. It's always multiply first, divide second. Okay? So watch this. This is very important if you don't want to lose any marks. Sorry, country music, I have to turn you off for now. 16.8, right? This multiplies that. And remember, these are all numbers, so we're going to figure out what that is in a bit. So we multiply these two, and then we divide by what is left over. And I know other teachers may have shown you a different way of solving proportions, but it is time to just reveal the quick and easy way of doing it, okay? Okay, so how do we solve this? I will actually have A is equal to, grab your calculator here real quick, and let's type this in together. 16.8 times sine of 72. You hit equals. I hit equals at that point when I multiply. Then I hit divide, sine of 52 degrees. And this is what you should get, 20.228. 20.28 because the 6 bumps the 7, 2, and 8 there. And that is centimeters. Okay. So that's how you solve for the side. Okay. All right, what does it ask for next? B down here, what does it say? Calculate the length of side C. Let's do that right here so that you can all see the diagram. Side C, we'll solve it right next to it. Pay attention to this part. Technically, do you have another pair now that is known? We know this angle and we know the side length, correct? So technically you could use that as your pair to set you up, but I wouldn't. Yeah, it might be wrong. So if you made a mistake here, it's going to translate to this side as well. So I'm going to stick to my original pair. So I'm going to go sine of 52 degrees over 16.8 centimeters. What am I going to do on this side here? I want side C. I want this side. What do I need for me to be able to solve for it? I need this angle, which I don't have at the moment, but I've got two angles, right? I've got these two, so I can find angle C. So let's do that real quick. I'm going to go sine of C over C like this. I will solve for angle C. 56? Yeah. 56 degrees. So this is important, but it's not my answer. We now substitute that in here, right, where sine of C is. So sine of 52 over 16.8. You may omit all the units if you do the work. I'm just showing you that it's okay to add all the units. As long as your final answer has units, in Essential, we do not take marks off until you get to your final answer. So we're going to go what? Sine of 56 over side C. Let's write in 56. I'm going to use a red pen. I'm going to write in 56 here so you see where I got it from. 56 is across the side I'm trying to solve, so that is very important to keep that in mind. So let's solve this. C is, you multiply, you divide. 16.8 times sine of 56 divided by sine of 52. Type it into your calculator, see if you can actually get this. Okay. Yeah. And here's where you need to have units. So if it's a side length, then it'll be the same as we were given, so that'd be centimeters. And there you have it. Does sine law work on right triangles, guys? The answer is yes. Sine law works as long as you have a pair, you can use it on right triangles, on oblique triangles, any kind of triangle. Okay? It works. What else did I want to say here? I think for now we're good. I'm going to ask you to practice this right away. Okay? So go to page 6. And I would like you to solve the following triangles. What does solving a triangle mean? It says it right here. Solving a triangle means to solve all angles, all sides. Okay, so that's what that means. So give this a try, see how you do. And so I would suggest use the left side of the triangle for some work, and then use the right of the triangle to do the rest, right? So you can kind of all fit that around the triangle. So give that a try, see how it goes, look at the example, and I'll come around and see if you need a little bit of a bit more guidance to get there, okay? Check how you're doing real quick. If there's anything that's off, let me know. So what I saw looked good. If you're still not sure, don't worry. You're gonna have chances to try this again. I will do that last one there. So let's go to the very last one. This one here. And so again, this angle right here, which you have a number for, you travel across, you see that this side length has a number, so that's your pair. That's what I would say is definitely the one I would start with. So I'm gonna go sine of 40 degrees over 36.3 centimeters. And you want to solve for side P. That's the ultimate goal, correct? But right now you don't know what that angle is. So technically all you could do right now is solve for side R if you wanted to. But if you have got two angles, angle P is a piece of cake. Anyways, 180 minus 34 minus 40. Okay, so angle P is 106 degrees. The province gives you a full mark for that. Whenever you have to find that extra angle, that you get a full mark. So this would be sine of 106 over side P, because now that you know that this is 106, you can solve for the side across from it. And so P is multiply and divide, right? This would be, sorry, I got this wrong here, 36.3. You got to make sure if your calculator starts with brackets, when you press sine, make sure you close the brackets, all right? Oh, it's the bottom. Trying to flip it or what? P is 54.29 centimeters. Okay. This is a mark. This is probably 2 marks using sine law. You get 1 mark for identifying that it is sine law, and then another mark for solving it. That's usually how the province goes about it. I asked you to solve the triangle, so you technically need side R. You would start the exact same way. Except for now we're going to use sine of 34. That's going to find us R, right? Because this angle's across from that. 36.3 times sine of 34 divided by sine of 40. That is 31.58 centimeters. Okay, so another sine law, but right now all we were solving for using sine law is side lengths. Now we're going to switch it over to angles. Okay. All right, let's go to page 7. If you're still writing this down, go for it. I'm going to leave it a little longer. Yeah, that's right, 130. Good luck. Who are you versing? Easy. They're pretty good. Okay. Here we go. Sine law to calculate the angle measure. Calculate the sizes. You know what? That's not how they would normally. They would say the value of angles A and C, but I hope you understand that that's what we're doing here. How is this going to change? Not much at first. Okay, so at first, this is the angle that you know. So you're curious, do I know the side length across from it? And you're saying yes, right? No doubt in your mind, this is sine law, okay? Because the province gives you a full mark for figuring out, is it sine law or cosine law? You only have two options, okay? So let's set it up. Sine, I'm going to go with the letters first. Sine of angle B over side B. And which one would make sense to solve for first? Which angle should I solve for first? I have this side length here, right? Which one can I solve if I have this side? This one goes with that angle, right? So right now, I have to solve for angle A first. That's my first go-to. So I'm going to go sine of A over side A. That's how this will work out for me. And maybe because you're still kind of new to this, go side A here and side B, and this is side C, right? So we've got our ABCs there. You don't need this, okay? This is optional on the exam. I'm just doing this for you to see. So I'm going to go sine of 81 over 123.2 is equal to sine of what? A, I don't know what A is, so I need to go sine with a letter next to it. So that's new. And then I do know the side length, which is 91.6. Look at the common error here on the side in this box here. Some students just don't like the sign in there, so they just go, oh, let's put A in there. Because that's how I solve for sides, right? So it's the same thing. It's not, okay? So you got to make sure you have sine of A. And now what? This is my variable. So I go to the number, you cross multiply up, and you divide down. It's always going to be like that when you're solving for an angle. So this is going to be sine of A. Please make sure you write down sine of A. And then you go 91.6 times sine of 81. All of that divided by 123.2. And normally I don't like another equal sign next to it, but it is actually okay to do that. So type this in, 91.6 times sine of 81. I hit equals when after I multiply. I just do that so that there's no confusion. Then I go divided by 123.2. And this is what I'm going to say. Hopefully you remember this. When you're trying to solve for an angle, you better have a number that starts with a 0 point something. If you don't have that, you're going to get a math error. It's not going to be able to solve it. So it's 0.7343. Just keep going. Just go dot, dot, dot. It's telling us that we're using all decimals. Do not clear it from your screen. Leave that on there. Leave the whole thing. Your last step, does anybody remember from last year, what do we do when we're solving for angles? There's this one. Do you remember this one? Angle A. Do you remember this one? Like the inverse sine? That's what you got to do. And followed by this number. And look, it's still on my screen, right? I'm going to highlight this. This is a must for showing your work when you're trying to solve for angles. So I press, and my calculator is shift, yours might be second F, or it might be, I don't know, maybe you have a variation, but I go shift, and I press sine, it calls the inverse on mine, and I just have to hit equals, and it will take the inverse of that number. So I just press equals at this point, so I get 47, and this is where your teachers probably made you round to a whole number last year for angles. Don't do it in this course, okay? Always 2 decimals. I've been trying to tell the grade 10s and 11s, the teachers, to make you round to 2 decimals so that in grade 12 it's not a problem. I don't know if that's happening. Are you guys rounding to a full degree? 2 decimals? Okay, so they're listening. Some. Okay. Okay, so that's your angle A here. Angle C, how will we find angle C? We now found a second angle. We've got 2 angles. So please don't do this again for angle C, right? Angle C is 180 minus 81 minus 47.25. It's so much easier than doing all of that work. And this is 51.75 degrees. Could we now solve for side C? Now that we have angle C, yes, we can solve for side C, right? So you will see that everything is connected. Let's do that real quick before I ask you to work on the examples there. So we start with the same pair as before. Start with the same pair. Then we're going to go sine of C over side C. I'm just putting letters on the other side for now. So sine of 81, 123.2. Sine of 51.75 degrees over C. Now you're back to what we started today with. Okay? We started solving for sides. So no inverse, okay? No inverse when it's just solving for sides. If you need to, if you're not highlighting or anything, I'm just going to put an arrow to that 51.75. And let's do this. So you go cross multiply and divide. Multiply first, cross multiply first, and divide. Okay. So side C is, give me one moment here. Why do I not have that answer on my key here? Oh, there it is, 97.96. Okay, I'm just going to say this because sometimes the province does check you for it. So let's do a check here. We've got angle A, and across from it is side A, right? We've got angle B across from it, we would have side C, angle C across from it. Let's write them down real quick. Angle A is 47.25 degrees. Angle B measures 81 degrees. Angle C, 51.75. Which one of these three should have the longest side across from it? Angle A, B, or C? Somebody not here or no? Sorry, which one is it? Angle B, right? Okay. Sorry, side B will be the longest side because it's the largest angle. So let's go and we figured out B, that's 123.2. The question gave that to us. Side A is 91.6 meters. Side C is 97.96 meters. So you've got the largest angle across from the longest side. Perfect, that's what you want. And which one is the smallest angle? It's this one, and it has the shortest side across from it. Okay, so this is the smallest, and it's got the shortest side across from it. That's how you know you've done, well, I'm not going to say it's always guaranteed you did everything right. You could still have made a mistake, but this is a little check. I think this was last year. The province just gave all sides, all angles, and it asked students, what's wrong with this? What's wrong with this triangle? And a lot of students missed it. They were like, the province had purposely put the shortest side across the largest angle, and students were like, there's nothing wrong with it. All sides are there, all angles are there. It's good, right? So sometimes they'll check, do you remember this property, right? Like, do you know that this has to happen or else it's not going to work, right? So that's that. So before you go, you've got almost 20 minutes, 18 minutes. I think you can do most of it. Go to page 8 and practice what we've just done here before you go home, okay? I'm going to say you can keep going. There's word problems. So I'm going to say all the way to 10. Yeah, go ahead. And if you didn't watch the video that you were supposed to have watched before you came in today, that's pages 2 and 3. Please do that, okay? Go ahead.